Yes, when you're ready. Well, how humans perceive time depends on the type of task that they're doing. The general consensus these days is that for many laboratory tasks and for relatively short times, up to a few seconds, they're using some kind of internal timing process, possibly an internal clock, which has been a popular idea. But the thing about humans is there are so many different ways that they can make time judgments. One thing that humans can do, which animals can't do, is make time judgments based on inferences. So, for example, they can use things like distance to calculate how long it would take to go somewhere. They can use the amount of information processing they've done to judge how long something lasted. So it depends really what type of time you're talking about. I mean, most contemporary theory generally distinguishes between what's called prospective timing and what's called retrospective timing, although the terms are a bit misleading. Prospective timing is when people know they've got to time something. So almost all laboratory experiments are like this. So for example, you say, I'm going to give you 2 tones which lasted longer, and they say first or second. Or hold down a button for 1 second. That's prospective timing. Retrospective timing is when you ask people unexpected questions about time. So for example, how long has it been since this interview started? Now, I probably haven't timed that time deliberately, but I can use my memory, I can use the number of things that have happened, because if I have a huge memory of this interview with lots of different events, then presumably it's lasted quite a long time. But if all I can remember are a few words, then it's probably lasted a short period of time. And humans in real life probably do that kind of, the second type of timing, quite a lot. And generally it's considered, as I said, that there are 2 different mechanisms for timing prospective intervals, usually short, and retrospective, with the retrospective being much more mysterious than the prospective. Internal clock models and various competitors to internal clock models which exist do really quite a good job of explaining how humans perform on laboratory timing tasks. There is research on this. There's anecdotes, of course, but there's also experimental research. But the experimental research, actually collecting facts, makes everything more complicated, because two studies on old people, which asked them, does time go faster now than it did when you were younger, suggested that people didn't really agree with that. Time seemed to pass most quickly when you were in your 40s, according to these studies. But that may not capture the entire thing. My mother, who is 90 years old and lives on her own, says, paradoxically, that the days last forever, but the months flash past. Now, you kind of know what she means, but how can this be? Maybe there are different sorts of time judgments. I mean, when my mother looks back over a time period, because she lives on her own and has a relatively restricted life, not many things have happened. So consequently, compared with how full her life used to be when she was younger, you know, have 3 months passed already, it seems very short. But every day, the time may seem to drag. So when you're actually in the day, because not much happens, time may seem very slow. But retrospectively, it may seem to go very quickly. We are trying to get going with, with a French collaborator, I'm trying to do a proper study of this. But if you get old people in the laboratory and do standard timing tasks on them, as I said, you find statistically significant differences between their performance and students, but nothing suggesting that their time perception is really abnormal. They're more variable, but they're more variable on memory tasks, they're more variable on perception tasks, they're more variable on attention tasks. They don't seem to have any specific problem with time. But more research in real life is needed, of course. I mean, one of the problems with laboratory studies the question of the similarities of animal and human timing is an interesting one. Obviously, animals don't have language, and presumably they don't have the capacity to make inferences about time, which, as I said, are so common in humans. I mean, we don't know whether animals can translate distance into time as we can. It's possible that they can, but we don't know how to ask the question. But the animal timing has historically been very important in determining some questions about human time perception, because the leading contemporary theory, or the most influential contemporary theory of human time perception in modern times, is called scalar timing theory. And this was initially invented not to explain human time perception at all, but to explain data from animals. And there was lots of data on timing in animals. So, for example, they get food every 30 seconds if they press a lever in a little box. And you find that if they have quite a bit of training, what they do, over the 30-second interval, they don't press the lever very much at the beginning, and then as it gets closer and closer to the 30 seconds, they press more and more and more. And their behavior has certain characteristics which are of theoretical interest. The idea was that they have some kind of internal clock-like mechanism, because they can't do it any other way. They can't do it by inference or knowledge. And towards the end of the 1980s, the leading theory of animal timing, scalar timing theory, began to be applied to humans. And it has more or less revolutionized the study of laboratory timing. It doesn't necessarily apply to real life situations or very long time intervals with humans.